pleasure today to introduce Professor Nathalie Fagel from the University of Liège in Belgium. Nathalie earned her bachelor's degree from the Free University of Brussels, after which she gained a master's degree in sedimentary geology and geochemistry at Paris University. She continued with a PhD in geosciences at Lille University, and she completed a postdoctoral position at the University of Quebec in Montreal, and has worked as a researcher at Paris University and the Royal Museum for Central Africa in Belgium, before taking up her current position in the Department of Geology at the University of Liège. Nathalie is an expert in clay mineralogy and sedimentary geochemistry, and her publication list demonstrates that she is an international scientist with a global network of collaborators, and that she has been lucky enough to complete fieldwork all over the world. So Nathalie, to get the interview started, I'm interested in your route to becoming a scientist with research interest in clay minerals. So what inspired you to enter clay research, and how were you introduced to the world of clay?
Actually, I was introduced to clay science during my complementary master year in Paris. During my master degree, we didn't talk a lot about clay minerals, but I was really introduced to the clay world by Hervé Chamlet, who was at that time professor of the University of Lille. So he taught us what we can do with clay, and especially working with clay in a sedimentary record, in oceanic drilling program and things like this. And I was very amazed by this kind of reconstruction of palaeoclimate or paleo-weathering condition. That was my first experience with clay minerals. And after this, the theoretical part of the master, I did my practice with Hervé Chamlet, and we worked together on a sedimentary sequence in the Japan Sea using an oceanic drilling project, and that was my first experience.
Yes, and I think you continued that collaboration for the rest of your career with Chamlet.
Yes, we had some connection, and during the last years, I was taking part of the editorial board of Marine Geology. So Hervé Chamlet introduced myself to the editorial board, and so I did a lot of review for Marine Geology because Hervé Chamlet was the editor-in-chief of this journal. Yes. So we had some close connection for such purpose.
Okay, and then coming back to sort of the here and now, what are your current research interests in clay minerals?
Actually, I changed a little bit the topic of my research, because about 10 years ago, I was contacted by some students from Africa, especially from Cameroon, and they asked me to initiate a proposal where they intend to use the clay minerals as a raw material to produce very utility stuff like bricks, tiles, and such kind of things, such kind of building material. Because for most of the southern country, building house is very expensive, and you may use the local raw clay that we may find in all the soil all around the house. It's very cheap, it's very easy, and the people may have quite good accommodation for not too much money. So I think that it's quite important to help the southern country, and especially Africa, to produce their own material building using the raw clay material.
Yeah, that sounds really interesting. And that kind of leads on very well to my next question, which is about how your research in clay minerals has allowed you to conduct field work all over the world. So where do you think has been the most memorable place to conduct field work? And I suppose that might be from a cultural perspective, but also maybe from a landscape perspective or a completely different perspective.
One of my experience, very intense experience, was in Burkina Faso, where we had a proposal, a cooperative a cooperation program on building material. And we did a field trip, and the conditions were quite difficult. The weather was above 43 degrees Celsius. There were no shadow. It was very, very hot. And we had to sample the clay in an outcrop without any shadow. And it was very intense. But by the way, the people there were very kind with us. And it's always a very good experience when you have the possibility to go on the field to meet the population and also to help the people. Or I hope we help them. So the PhD student did his thesis, he finished his thesis, and now he has a position at the university in Burkina Faso. So I hope I'll help him a little bit to conduct his work.
Yeah. And I guess also a very different landscape to conduct field work in as well, maybe.
Yeah, we were in the Sahelian part of Africa, so very, very dry. There are a lot of coal that were dead just around us due to the weather condition. And just at the side of the site, there were a lot of bricks that the people made by themselves, and they were just leaving them on the sun, under the sun, to be dry, and then they may be used to build the house just a few 100 meters far from the outcrops. So it's quite impressive to see the quick chain of production from the sampling to the construction itself.
Yeah, and I suppose making the use of the local raw material, but also the local environmental conditions in terms of the temperature to help produce the material.
Yeah, for sure. But it's more easy in this part of Africa. You have not too much rain, so the raw clay material are quite easy to use, and you don't have any influence of the rain that may destroy or that may change the volume of the bricks. So it's much more easy in such kind of conditions.
Yeah, so then my next two questions are kind of quite big picture, I suppose. I was interested, in your opinion, what are the big clay mineral research questions that still...
A tricky question. I think that many work have been done on clay, but we still don't use the clay as far as we can. I think that the geochemical composition of the clay size fraction remain quite useful. I did some work with radiogenic isotopic composition of clay, of marine clay, in order to reconstruct the provenance of the material, and then indirectly to reconstruct the past circulation that may be wind circulation or oceanic circulation. So I think that we have still some work to do by using the geochemical signature of clay to better understand their formation process and their evolution in the sedimentary record. It's quite complex. Clay minerals may be complex in terms of composition. When you have smectite, you have a world of different kind of smectite, and the same for palygorskite or for every clay, or more or less, except kaolinite, which are quite simple material. But I think that there are not so many work up to now on the geochemistry of clay and of their potential for study.
Yes, and I guess from a paleoclimate perspective, there's just so many proxies that you can now use to try and reconstruct past environments that maybe sometimes clay minerals are seen as a kind of more complicated option to try and...
Yeah, that's for sure. But anyway, I think that to identify the provenance of the sediment, I'm quite convinced that the clay size fraction remain one key point to take into account. Because you know that the clay are fine particles, and so they are not supposed to be retransported by current. So as soon as they are they sediment in a specific place, they are not supposed to be retransported. So you have a good record of the provenance of the material in the clay minerals. That's my feeling. And
yeah.
there were not so many work on this, specifically on the clay size, the geochemistry of the clay size fraction. I tried to push a little bit, but indeed it's quite long. It's time consuming. And maybe you may have some more direct information easier. But I'm still convinced that it brings a lot of information that may be quite important to get a full understanding of a topic.
Yes, and I think it makes sense to use as much information as available within the sediments in terms of all the different proxies, including the clay minerals.
Yeah, and if you just use the mineralogy of the clay, you have just a part of the singer, part of the history, because a smectite may be of different origin. You have a mixing of different smectite of different origin in the sediments, and it's quite important to decipher those different smectites. For sure, it's more time consuming, but I think it's quite interesting to focus more on those details of the composition of the clay.
Okay, yeah, and then my next question is maybe going to be linked to your more recent research, which is which global challenges do you think that clay science can help to address?
I think that in order to understand the palaeoclimate evolution of a site, it's quite important to have a broad overview of different proxy, and clay are one of the proxy that we may use to understand better the weathering condition, the influence of the precipitation, or the influence of the temperature. So it's just a part of the puzzle, if I can say like this. If you, for instance, if you are working on lake sediments, you need to better understand the weathering condition in the watershed to better understand your sedimentary record. And the weathering condition are part of the palaeoclimate condition. They reflect the palaeoclimate condition in addition to other regional tectonic setting and so on. But yeah, it's a tricky question. Sorry.
Yeah, no, well, we are doing these interviews once a month for the next 12 months to celebrate the CMG's Jubilee year. And I think for this question, there will be such a huge range of answers about how clay minerals can help answer global challenges. So it'll be interesting to see. My next question is about what aspect of your clay mineral work gives you the greatest satisfaction? So do you think you most enjoy teaching, conducting research, conducting field work, writing up the results as papers? Which is the most satisfying for you?
As a teacher, I think that it's quite important to keep a good equilibrium between the different aspects of a scientist. So when you teach, you may present your idea to the students, you may explain them how you deal with your research. You may also explain what is not working or what is working. So it's quite important to get a quite realistic view of your research for yourself and maybe for the students. To tell them that in science there is no verity. Is it this word in English? You may be confident in one point, and then there are some discovery that tell you that you were wrong, but you have to accept this. That's the challenge of science, I think. And it's quite interesting to evolve through your career by your experience, but also by when you're reading different papers, you may change your idea about specific questions. So I think it's quite important to teach, to continue to evolve in your research. That's one point. Mm-hmm. And also, I think it's quite important to do some field work, to have more experience, to explain to the student that it's not so easy to collect a core, to do all the research, to get the money to do the what you want to do, and to publish a paper, and to finally have your paper in your hands, and the paper is available to the whole community or the people who are interested in the topic. So it's another part of the deal. And when you are doing research, it's important to keep in mind why I'm doing this, what's important, or I will do it. So you have to keep the different steps clear in mind. And I think that when you teach, you also have a guideline, and you have to keep this guideline during your research, like during your lecture. Mm-hmm. So I think that it's quite important to keep all aspects all together to be maybe a good professor or good research or a good investigator. For me, there is no difference. I like to teach. Yeah. Sometimes it's boring, but it depends on the students, and you have to give your enthusiasm to the students. That's what I try to do. It's not always working, but I try to do my best to keep them, to show them that science is not a direct line. We don't follow a line. It's more a labyrinthic pathway, and it's normal. You may do some error, and you start again, and sometimes it works, sometimes it doesn't. So I think it's part of life, and you have to convince students that it's normal in research. It's like this, and you just need to be clear with your hypothesis to define a way or a work plan, and then you see if the work plan is working, and if not working, you start again. And it takes time, but that's scientific life, you know?
Yeah, absolutely. And actually that leads on really nicely to my next question, which is, have you had any experience when using clay minerals for your research where you failed to produce the results that you'd hoped?
I don't remember any really bad experience about clay minerals at the moment. For sure, I had some negative experience, but for the moment, I can't remember. So I think it's normal to fail in some point, and you have to start again and to find a new enthusiasm for another topic or for another study, and you start again. So I think I imagine that I forget such kind of bad experience.
Yeah, well, I think that's good that nothing immediately springs to mind as like a huge disaster that you've had. So
yeah. For me, it's not really important if it's a disaster or if it's working well.
It's always just a process of...
Yes, for me, it's a process. And the most difficult part is to diffuse your study. And it's more and more difficult at the moment. There is a huge stress for publication. And it's quite difficult to keep your publication synthetic and easy to read for the general audience. But for me, it's the most difficult part of a job, but it's very important to diffuse your knowledge, to diffuse your idea, your experience, even if they are not so positive, if the results are not so important. I think that the process remains the most important.
Yeah. Okay. And then what advice would you give to early career researchers starting a career in clay mineral science? And I suppose this advice might also apply to early career researchers in any scientific discipline.
It's again a difficult question because it's quite personal.
Yes.
When a student came and asked me, I would like to do a PhD, first of all, I try to get some idea, why do you want to do a PhD? For you, what is a PhD? And I try to explain to the student that it's not so easy, and you have to be really engaged during 4 years at least, 4 or 3 years, it depends, for your PhD. It's not a very easy adventure. And I try to test the student to see if it's just an idea, okay, I don't know what I would like to do, and so just start a PhD. It's more easy than to find a job. But I think that's a bad bad idea to start a PhD without knowing what is really a PhD. You have to engage yourself for a long time, and you know that it won't be as simple as you can imagine. So for me, it's very important that the students face such kind of real information. To not deny the fact that, okay, it's an easy experience, I will do it, and let's see how it works. You have really, you have to select a thema that you are very interested in. Otherwise, you won't finish your PhD. And it's always very difficult when a student didn't finish his PhD for himself, but also for the promoter. I had some bad experience on this point, and it's always very frustrating when you don't arrive to, you are not able to push the student till the end of the PhD. It's always some way your fault as a promoter. So it's difficult to admit and to understand, I think.
Yeah, I think it's a challenging process for all involved, isn't it? And often there's not always necessarily someone to blame. It just didn't work out for that person and that project.
It's a difficult equilibrium between the promoter and the student. You have to give the chance of the student to develop by himself his research, but you have also to give some guidelines to keep on time for different deadline, and it's not very easy. I had 17 students that finished a PhD with myself, and I have still 6 students ongoing. It's always a challenge for me and for them. So I'm very happy when they finish the PhD and where they are happy to get the diploma.
Yeah.
And even if they don't continue in science, because it's very difficult at the moment to find a job as a professor, it's very tricky, at least in Belgium. I don't know in England, but here it's very tricky. There are not so many positions. So you have to say that the students may have a good job in other fields, but still the experience as a PhD student has to be a plus for their career, whatever they do.
Yeah, I agree. I think, having a PhD is a fantastic experience, regardless of what you end up deciding to do.
Yeah, actually, you are more or less free for 3 or 4 years.
Yeah.
You do only what you want to do, and if you want to give some lecture, it's possible. You may have some student or not. It's really dependent of the students. But the liberty, it's very wonderful. And after, you have always some constraint about administrative and so on.
Yeah.
And it's getting worse when you are going older. So it has to be seen as parenthèse. I don't know if this word is in English. A bracket. It's a time into brackets.
I see what you mean. Yes. Yeah.
Like a dream, not a dream, but it's a wonderful world for 4 years, and you do what you want, how you want, and you just have a deadline that you have to respect. And that's all, no?
Yeah.
More or less.
Yeah, it's normally, I think for most people, it's a very nice time of their lives when they're doing their PhDs.
Yeah.
Yes, so finally, just a few light-hearted questions to finish the interview. I wondered if you have a favorite clay mineral and why?
Yeah, I was thinking a lot about this. Actually, my favorite clay minerals is probably palygorskite. Okay. First of all, the word sounds very exotic.
Yeah.
And actually, I should say that I don't know what's the etymology of the word. I didn't have the time to check this before the interview, I'm sorry. But for me, it's quite exotic, that's for sure. And then maybe when I did my PhD, just at the beginning of a PhD, I worked on a marine drilling sequence where we have a lot of palygorskite. And the palygorskite were coming from with the wind from the southwesterly monsoon. And it was coming, it was delivered by the Arabian part of East Africa, from Somalia and Arabia. And it was delivered by the southern winter south monsoon. Okay. And we just used the ratio between palygorskite and illite on the X30 patterns. And we were able to reconstruct the intensity of the monsoon. So it was a very easy parameter, very easy to measure, just the age of the two minerals between illite and palygorskite on the X30. So very, not positive, but very direct measurement. Anybody can do it. And we were able to reconstruct the evolution of the monsoon for the last, for about more than 1,500,000 years, just between the Pleistocene and the Pliocene. Yeah. So that was quite funny to use this very simple parameter to reconstruct the monsoon for myself. Maybe that's why I like palygorskite.
Yeah, I think that's a nice story.
When you look some scanning electron microscope, palygorskite are so nice. Tiny minerals, very beautiful fibers. And so I like them. I don't know.
Yeah, no, I think these are all excellent reasons.
Of my experience.
Nice. Fantastic. And then my final question is, which clay mineral researcher, past or present, do you think you might like to interview?
One of the most important papers I read during my postdoc was the paper published by Reinhard Petschik. He's from Germany, and he was the first that published the relationship between the composition of the clay minerals in marine sediments and the distribution of the water mass, deep water mass. And he was able to reconstruct the clay mineral signature of the North Atlantic deep water by contrast to the Antarctic bottom water. And for me, this publication was quite very important. And I start to investigate more the use of clay minerals to reconstruct past deep circulation during my postdoc. And so for me, this paper was very important, very impressive, and I will be very proud to write this paper.
Yes.
So for me, it's an important paper.
Okay, thank you. Well, Professor Nathalie Fagel, thank you very much for letting us interview you to celebrate the 75th anniversary of the CMG.
Thank you to invite me for this interview.